Hey, welcome to session 7 of the flipped classroom for AP Calculus. Today we're going to talk about one-sided limits, the squeeze, or sometimes it's called the sandwich theorem, and a special trigonometric limit. The squeeze or sandwich theorem just says that if one function h of x is between two others, in other words, mathematically that would be h of x is greater than or equal to f of x and less than or equal to g of x, and the limit of those two outside functions equal L, in other words the same thing, as x approaches some value c, then the limit of the inside function equals L as x approaches c. Example, consider the function 1 minus x squared over 4. Okay, that's one side. Think of it as a piece of bread if it's a sandwich. The meat would be h of x. And the other piece of bread would be 1 plus x squared over 2 for all x not equal to 0. Now, let's say I want to see what that function is doing as x approaches 0. Since both the outside functions equal 1 when x equals 0, the two limits are the same. Therefore, by the squeeze theorem, the limit of the inside function, h of x, has to be 1 as x approaches 0. Here's a graphic example. The red line would represent our inside function h of x, the blue line and the green line, the two outside functions, or the pieces of bread. As you can see, as x approaches 0, these functions all have the same limit. One-sided limits. Sometimes the limit does not exist and can be defined as either a right-handed or left-handed limit. These would be one-sided limits. Up to now, we've been talking about two-sided limits. Consider the following function. If I asked you what's the limit of this function as x approaches 2, you would say it doesn't exist because the y values approach two different values, namely 2 and 1. But now we can talk about a one-sided limit. A one-sided limit can be defined as right-handed or left-handed. Left-handed means approaching the value under consideration, in this case 2, from the left or negative side on the x-axis. As you see, that limit would be 2. As I approach from the right or the positive side, as I approach 2, the limit would be 1. The notation for right-handed limits is the limit as x approaches c with a little plus sign as a superscript. For left-handed limits, the notation is as x approaches c with a little minus sign as a superscript. This is a little important theorem here. If the limit as x approaches c from the right, positive side, equals L, and the limit as x approaches c from the left side, negative numbers, equals L, then the two-sided limit as x approaches c exists and is equal to L. So that's basically, in words, what you guys have been doing. A two-sided limit, the limit has to have the same value as you approach from the left and the right. Finding one-sided limits algebraically. Let's find the limit as x approaches negative 0.5 from the left of f of x of the function square root of x plus 2 quantity over quantity x plus 1. Let's try substitution. When I put negative 0.5 in, for the numerator of that fraction I get 3/2. The denominator becomes 1/2, and 3/2 divided by 1/2 is 3, so the limit would be the square root of 3. Not so bad. The last part of this section is about a special trigonometric limit. And that says that the limit of the sine of x, the whole thing divided by x, as x approaches 0, it always has to be approaching 0 for this special trig limit, will always equal 1. We will prove this in class as it's a fairly complicated proof, hopefully that is. Problems to be considered during class would be pages 108 to 111, numbers 15 through 32. Thank you, and we'll see you tomorrow. Bye.